Hey guys, section 4.3 is all about angle relationships in triangles. So a few of the things I mentioned I'm going to have already mentioned in the other videos, so they may seem familiar. Hopefully they do. Triangle sum theorem. This one's going to be really important for a lot of the problems that we solve from now on. So the sum of the angle measures in a triangle is 180 degrees. I know I mentioned that in the last video. All right, but if you take all three angles inside, so the measure of angle A plus the measure of angle B plus the measure of angle C, it is always going to equal 180 degrees. Okay? The right triangle corollary says that the acute angles in a right triangle are always complementary. So if you remember back to chapter 1, we talked about complementary angles. It means that they add to 90 degrees. Okay, so which makes sense, right? If the sum inside has to be 180 and this one is equal to 90, then the other two together are going to have to equal 90 as well. So if angle C is 90 degrees, measure of angle A plus measure of angle B has to equal 90 degrees. And then this last one I know I mentioned in the last video too, the equiangular triangle corollary says that the measure of each angle in an equiangular triangle is 60 degrees. All right, equiangular means that we have three congruent angles, which means if I have 180 total inside and I divide that by 3, that's where that 60 degrees comes from. So measure of angle A, B, and C, each of them is 60 degrees when it's an equiangular triangle. Okay, then let's take a look. We got some new vocab down here. These words will look familiar, but not in a math context. So let's talk about them together. So draw yourselves a triangle, and on one side of the triangle we're actually going to extend the side. Okay, so in the triangle I'm going to name this angle 1, angle 2, angle 3, and then that outside one there I'm going to call angle 4. So interior is all the points inside a figure. Exterior is all the points outside a figure. That should all be familiar, right? Inside, outside, interior, exterior. So now we're going to talk about interior angles. So interior angles are formed by two sides of a triangle. Exterior angles, however, are formed by one side of a triangle and the extension of another side. Okay, so when we look at our picture that we drew over here, the interior angles are the ones that are inside our actual triangle. So angle 1, angle 2, and angle 3 are interior triangles, or interior angles, excuse me. Okay, 1, 2, and 3 are interior angles. Angle 4, however, angle 4 is made up by this side of our triangle and then by the extension of this side of the triangle. So angle 4 is an exterior angle. Pretty easy, right? Inside, outside, interior, exterior. Those are some words that should sound familiar. Then we've also got what we call remote interior angles. Okay, so we are going to draw that same picture that we just had. So we had a triangle like this, and we had this bottom piece extended here. 1, 2, 3, and 4. Okay, so remote interior angles. Each exterior angle has two remote interior angles. A remote interior angle is an angle that is not adjacent, an interior angle that is not adjacent to the exterior angle. So remember in the last picture we identified that angle 4 right here is the exterior angle. So the remote interior angles for angle 4, they're the ones that are not adjacent to angle 4. So remember that adjacent means next to. Okay, so we're looking for the two angles that are inside the triangle that aren't next to angle 4. So in this case, that would be angle 1 and angle 2, because angle 3 is adjacent to angle 4. All right, we're going to do lots of examples of it, so don't worry. Then we have this exterior angle theorem. The reason that those vocab words, interior and exterior and remote interior, the reason that those are so important is because of this theorem. All right, the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So take a look at the picture that we have down here. Looks really similar to the one we actually drew up there, right? In this case, angle 4 is our exterior angle, all right? And angle 3 is the one that's adjacent to it, which means that 1 and 2 are the remote interior angles. So I'm going to circle angles 1 and 2 because they're going to be important. They're the sum. We want their sum. Angle 4 is equal to the measure of angle 1 plus the measure of angle 2. So the sum of the remote interior angles is equal to the exterior angle. And we'll do some examples that'll help make sense of that, okay? The last theorem we got to talk about is the third angles theorem. I also kind of refer to this as the no choice theorem, and I'll explain why in a second, but you might want to jot that down, the no choice theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles must be congruent. All right, so take a look at our picture here. Angle A has 2 arc marks and angle D has 2 arc marks. So that's telling us angles A and D are congruent to each other. Angle B has 1 arc mark, angle E has 1 arc mark, so those ones must be congruent to each other. Well, since we know that the sum inside has to be 180, and these two angles are congruent, and these two angles are congruent, there's really only one way for this to happen. That means that angle C has to be congruent to angle F. You've got no choice but to say that they are congruent because the other two sets of angles are already congruent, and they have to add up to 180 degrees. Okay? So that is our third angles theorem, like I said, what I refer to as the no choice theorem. All right, there are all your learning targets for section 4.3. So read through those, kind of rate yourself so far. And we're going to do a couple of examples. And these are going to be some pretty basic ones because you guys are going to do some more complicated ones on your own. All right, so number 1 wants us to find the measure of angle C. We're given the measure of angle A and the measure of angle B. We know that the sum has to equal 180 degrees. Okay, the inside of a triangle is always 180. So the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 degrees. And we can grab our calculators and figure that out. So 43.85, and the measure of angle C is 180. So, oops, we get that the measure of angle C is equal to 52 degrees. Okay, inside always has to equal 180. So you can always double check and make sure that those actually add up to 180 once you're done. Okay. Number 2, the measures of acute angles in a right triangle are in a ratio of 3 to 2. What are the measures of the acute angles? So the important part here that you have to pull out is it's the acute angles in a right triangle. And remember that the acute angles in a right triangle are always complementary. Okay? So in a problem like this, anytime you guys see the word ratio, I want you to think x. Okay? We have to put an x in there somewhere. They're in a ratio of 3 to 2. So we could call one of them 3x, and we could call the other one 2x. But we know that acute angles in a right triangle have to be complementary. which means if I take those two angles and add them together, they have to equal 90 degrees. Okay, then we can just solve for x. So we get 5x equals 90, divide by 5 and we get x equals 18. But that's not what it asked for, right? It did ask for the measures of the two acute angles. So we can just call them angle 1 and angle 2. Measure of angle 1, measure of angle 2. Well, one of them is 3x, so 3 times 18 is going to give us 54 degrees. And then the other one is 2x, so 2 times 18, which gets us 36 degrees. And if we double check our answer at the end, 54 plus 36 equals 90 degrees. So I know that I got the right answer. Cool? Question 3. Let's go down a little bit, Miss J. All right, so question 3, we've got measure of angle A is 38 degrees, and we've got measure of angle B is x. We don't know anything about angle C, but we do know that these two sides have tick marks. All right, so if we think back to before, then we know that if those two sides are congruent, the angles across from them are also congruent. So that means then that angle C and angle B have to be the same, which means since angle B is x, angle C is also x. Okay, and now we can use our triangle sum to find the measure of x. Okay, so angle A is 38, angle B is x, angle C is x. If I add all three angles together, I'm going to get 180 degrees. Okay, so 2x plus 38 equals 180, and we can subtract the 38 from both sides to get 2x equals 142. And divide by 2 to get that x is 71. Okay, so there's our x right there. And this was because we started out with these two congruent sides, right? Which gave us then that the angles across from them were also congruent. And then we were able to add them together and get to 180 degrees. Cool? All right, question 4. That diagram alone should tell us we're doing something different because this side is extended. Okay, that means then that we're talking about an exterior angle. So an exterior angle is equal to the sum of the remote interior angles, which means we have to first figure out where our exterior and remote interior angles are. So since this one's on the outside, that's my exterior angle. Okay, and it is going to be the sum of the remote interior angles. So that is going to be these two angles here. So the measure of angle FGH is going to equal the measure of angle H plus the measure of angle J, because H and J are the remote interior angles for angle FGH. So 126 equals 6x minus 1 plus 5x plus 17. And we can start to simplify. Let's see, we get 11x plus 16. So if we subtract 16, we get 110 equals 11x. And divide by 11, we get that x is equal to 10. Okay, but the overall question asks for the measure of angle J. So angle J is down here, that's the 5x plus 17. So if we plug 10 in there, measure of angle J, 5 times 10 plus 17. So 50 plus 17, we get 67 degrees. Okay, so the hardest part there is just going to be figuring out the exterior angle and the remote interior angles and just making sure you set up your equation correctly. Okay. Looking at number 5, we've got this triangle HIJ. Measure of angle I is 47 degrees. The measure of an exterior angle at H is 120 degrees. Find the measure of angle J. So the first thing we have to do here is draw ourselves a picture. Okay, because looking at that, we have no clue what's really going on. Okay, so let's draw a picture. And it tells us that we have an exterior angle. So I always just go ahead and pick a side to draw my exterior angle on. Okay, the exterior angle is at H. That means that one has to be H. Okay, the other two, it doesn't matter. But I'm going to go here for I and here for J. But I know that this one has to be H because that's where my exterior angle is going to be. So my exterior angle is right here, and I know that that's 120 degrees. I know that my exterior angle is the sum of my remote interior angles. So that means then that I and J are my remote interior angles. So if I could figure out what those two are together, I know it has to be 120. Let's see what else they gave me. Oh yeah, angle I is 47 degrees. So I'm going to put 47 in there. So that means then that the measure of angle I plus the measure of angle J has to equal the 120 that I was given as my exterior angle. So 47 plus the measure of angle J is 120. And you can just subtract the 47 over, and we get that the measure of angle J is equal to 73 degrees. Okay, the biggest part about problems like that is going to be drawing that picture and making sure you've got your letters in the right spot. Okay, we'll do lots of practice with it though, don't worry. And the very last one, okay, take a look at number 6 here. When I look at it, I see that this and this are the same. That means that this angle right here is also 58 degrees. And I see that this angle here is the same as this one. That means that this one is 66 degrees. All right, so this is that third angle theorem, that no choice theorem that I kept talking about. It means that whatever this angle is going to be the same as this one. Okay, so I think the easiest way to do this is figure out what this angle is. All right, we know it's got to be 180 total. So if we subtract off the 58 and the 66 that we already have, so if we subtract 124, we get that the measure of that angle is 56 degrees. That means that this angle is also 56 degrees. So 2s plus 10 has to equal 56. And then we can solve for x. So if we subtract 10, we get 2s equals 46, which means s is going to have to equal 23. And that's by our no choice theorem, that third angle theorem. Okay? Hopefully you guys are cool with that. We're going to do lots of exterior and remote interior angle problems. And hopefully the 180, the sum being 180, isn't that new for you. Okay? If you have questions, make sure you wrote them down. We'll talk about them in class. I will see you guys later. Okay? Bye.